Good morning, everybody. My name is Jarmaine Magoai from the National Museum just in town. Today, I'll be giving you the overview of the genus Atherigona in Southern Africa. Okay, commonly known as shoot flies, Atherigona rondani 1856 is one of the most species genera of the family Mosquidae, commonly known as houseflies. The genus consists of two subgenera, Atherigona sensostricta and Atherigona acritocrata grimshaw. There are approximately 260 described species of Atherigona, of which we have 177 described species in Afrotropical region and about 85 in Southern Africa. Looking at the graph given here, we can see that the number of Atherigona species described has increased over the years, and for this group, we have key contributions. Because I'm talking on Southern Africa, I'll be giving you a few key contributions. I will start with DK. He has published a lot in the late 1980s up to early 2000s, and he's one of the people who have given us a key that we can use to describe the species in Afrotropical region. And we also have Diming, who has extensive contributions across 1970s to, we have his publication that came out last year, 2014, and we have a key from him in 1971 that we also use for our descriptions. We have Berhard Muller, who also did the most recent major revision in Southern Africa on Atherigona sensostricta species, and he also provided us with a key that we now use for our species. These publications collectively highlight the growing taxonomic work on Atherigona in Afrotropical region and Southern Africa. I must say, there have been notable efforts towards the study of Atherigona. We do have post-Muller work. We have Diming, as I've mentioned. He published on some species in Namibia, and we have myself and Muller. We have published a record of new species we have published new records in Lesotho also late last year. However, it is to be noted that there is still limited research on Atherigona species in Southern Africa. For example, we have Eswatini, previously known as Swaziland. We can see there we only have 3 records, and also we can see for Botswana there we have 15. So there's still work to do. Why shoot flies? Most of Atherigona sensostricta species are pests of cultivated crops. Larvae feed on Poaceae, example maize, millet, wheat, and these are stable crops for most African countries. Example species, we have the sorghum shoot fly, commonly known as the seedling pest, Atherigona saccata. It is known to occur in Africa. The larvae feed actively at the growing point of the seedling and causes the central leaf to die and dry out, creating the characteristic dead heart symptom, especially in sorghum, but also millet and maize. Infestations have resulted in up to 90% yield loss across Africa, Asia, and some part of America, which is, it's high. And that will maybe include things like late detection or maybe wrong use of, controlling methods. Yeah. This is a photo of the sorghum shoot fly. We have the egg as well. We have the larva there. Though Atherigona acritocrata species feed on decaying organic matter or other small invertebrates, Conversely, we have Atherigona acritocata orientalis that is now recorded. It is recorded as an agricultural pest of crops such as peppers, tomatoes, and sorghum. Muller and I recently published on new records for Lesotho, adding to the growing knowledge of Atherigona species. Our study is based on the knowledge that there is limited research on Atherigona in Lesotho and generally Southern Africa. And it is crucial for the economic and agricultural research community. Our study material were collected from Lesotho in 2021, 2022, 2023, and this study has led to new generic and species record, and we are grateful for the field expeditions. This map is adopted from Mitchley 2023, and it shows it is a map of major collecting sites in Lesotho with vegetation types. The white indicating historical collection sites, and then the red indicating sites from recent expeditions. The arrows are showing areas that are not really visible on the map. Our research findings, we have 8 species described in our paper, and out of 8, we have 1 new species. We have named it Atherigona jodensi, and this is the typical male, and we have the trifoliate process there, and then the hypopygial prominence that we use to identify this new species. Most Atherigona species can only be identified using specialized structures, particularly the male trifoliate process or female tegard aid, along with external color features. Most descriptions are based only on males, and unless specimens were collected in copula or in large series from the same type locality. It is to be noted that the female morphological characters alone are generally unreliable for species identification and cannot reliably be used to associate them with male species, as males and females are sexually dimorphic. We have a male here and a female. They both belong in the subgenera Atherigona sensostricta. Thanks to Muller for this diagram. It helps a lot when we have to identify the species. This is to show how we describe the coloration in the species. So for an example, we're having figure 2, we're having the frontal vita. Some of them, they can be entirely yellow, and some of them, they can be entirely infuscate. And on figure 3, we have the antenna as well. We have some that can be entirely yellow and some that can be entirely infuscate, depending on species as well. We have the scutum, and with the scutum, we usually look at the dorsoventral vitae. The range is usually from 2 to 4, depending on the species as well. We have the legs, we have the abdomen. We usually, for the legs and the abdomen, we usually use marks. They have specific marks to them that we use to differentiate between the species. For an example, you can see for the legs, we can see for the female here, we have what we call a mark. And for the female, we can say the forefemur has, it's yellow, but then the apical half is infuscate. So that's how we, when we look at external morphological features, we basically look at the marks and the colors. Okay, this is a male trifoliate process, and this is a female tegard 8, just to give you a visual representation of the genital features, genitalia features of the species. And in our Lesotho paper, as highlighted there by red blocks, you can see another feature that we look into. We have the hypopygial prominence, It also comes in different shapes for different species. The top two, when we describe them, we usually say they are knob-like. But when you dissect, you can see that even though they are knob-like, but they are different. So it is very important, I must say, it is very important to dissect these species in order to identify to specific species. So for interest's sake, since most descriptions are based on male terminalia, there's a biological note in Deeming 1971 on courtship display. Most of the people refer it as courtship ritual. So in this case, what happens? The male will approach the female, and usually in this case, the female is immobile, doesn't move, usually facing the sun, resting, and the male will approach, and then the male will position himself alongside the female, and he will extend his the trifoliate process in such a way that he's able to present it to the female. And this behavior can take up to an hour. What the male does during that time, he uses his trifoliate process. He will be moving it up and down so that the female can see that he's there and he's willing to mate with her. So, and during the time, the female needs to be really impressed. If she's not impressed, she won't move, she won't do anything. But should the female be impressed, then the female will open up her wings and her abdomen so that the male can position himself so that he can use his trifoliate process to insert in the female abdomen, and mating can happen. And the mating session as well, it takes time. So it is very important for the male to really impress the female, because it takes time for the courtship and then the mating. In conclusion and future direction, where do we fly next? We have a paper coming up soon. It will be based in Angola, so I did not include Angola since it's not part of the definition of my Southern African countries, but we are looking forward to it, and we would like to also acknowledge Dr. Terence Abelingen for his contribution for this paper. He participated in Lesima 2022 expedition. He has a poster outside with the Lesima expedition. You can go and check it out. And we are looking forward to more field work. And also we have species awaiting identifications in museums. We are looking forward to a collaboration for DNA barcoding, and also I just want to acknowledge Dr. Genevieve Thuren, as she will also be taking part in this DNA barcoding. So we'll be looking into matching our females with the males, and try to describe females, more of the females as well. So in general, we'll be contributing towards species diversity, and we will be expanding on the taxonomic knowledge. And we would like to thank the collectors and their respective institutions, and acknowledge my institute for the support. And also we are acknowledging the participating countries' authorities for their for allowing the collectors to collect in their countries. Thank you.
Thank you, Jarmaine. Any questions? No questions? There's a question at the back.
Hi. Thanks for the talk. I have a slightly niche question that I'm wondering about in my research on carrion ecology. And in the literature, it's very, there's no agreement whether or not Atherigona are forensically significant, but they show up in large numbers at carrion. So I'm just curious if you have any thoughts or opinions on Atherigona some species being forensically significant?
Well, I don't know in detail, but as you've heard, I've mentioned them being mostly pursed. So I think it's something that maybe one can go and to think about. Let me just say, I'm not sure.
All right, thank you. That's unfortunately all the time we have for questions. Thank you, Jarmaine.
Thank you.